In this video, we're looking at rotational symmetry. So this is one of the two main types of symmetry that we're going to be covering. Remember, the first one was line symmetry. Now, rotational symmetry occurs when a shape can rotate around a single point and it will fit exactly on top of itself at least once before we do a full spin or a full revolution, which is 360 degrees. Now, the center point is called the center of symmetry. The number of times a shape can rotate and actually fit on itself in one revolution is what we call its order of rotational symmetry. So below we have a fan, and the easiest way to identify how many times what this order of rotational symmetry is to label the blades of the fan. Sometimes if it's a different shape, you'll label corners. So I'm going to label this 1, 2, 3, 4. So if I rotate this way, my 1 is now down here, 2 is down here, 3, 4. I can then rotate it again, and this time I have 1 on the bottom, 2, 3, 4, and we can rotate it again, 1, 2, 3, 4, and then finally if we rotate it one more time we get back to the original. Alright, so the number of times we were able to rotate it and it still have the exact same shape was once here, 2, 3, and then finally 4 to get back to the original. So the center of symmetry, obviously with this shape, is this circle in the middle, and you could put a dot in each of these as that would be your center of symmetry. And again, the order of rotational symmetry for this blade is 4 times because we can rotate it. So here's we always label at 1, then it moved here, same shape, same shape, same shape, and then eventually we're back to the original. So it's important to label something so you can keep track of how many times our shape has been rotated. So if I'm looking at this triangle here, a more generic shape, I could label this as 1, 2, 3. So this time I've identified the corners. I could again rotate it around a point in the middle here. Right, so I'll draw in all my little circles. This time we have 1 down here, 2 over here, 3. We could rotate that again, and this time we have 1 here, 2, 3. And finally, we rotate it back, 1, 2, 3. So this has an order of magnitude that is 3. You can rotate it 3 times and get the exact same shape.